All right. We're starting to see people flow in. Welcome, everybody. Welcome. We're going to get started in a couple of minutes. But the first thing we would love for you to do is pop in the chat, which is over here, and tell us where you're calling in from. So I'll put a message here. Where is everyone calling in from? So just pop your answers in the chat. We'll let the room fill up for a couple of minutes, and then we will get going. So everybody sit tight.
Sounds good.
All right. We got some folks. All right. Northern California, Portugal, Bangalore, love it. Munich, San Diego. Wow, we got a global audience here. Mumbai, Bangalore, love it. Valdez, North Carolina. Jakarta. Kevin, have you ever had such a global audience?
Not at this hour. I'm impressed with people pulling some evening hours to join. Thank you.
I love it. Portland, Oregon, my old hometown. Arizona, Kuala Lumpur, love it. Bangalore, Lima. I've always wanted to go to Lima. I'm just putting it out there. What other amazing places are we seeing? Kabul, awesome. San Diego. Everybody, welcome to the show. We're going to be learning a lot today. I'm your host, Ryan from Intel, and we'll introduce Kevin in a minute, and we'll get things rocking. But make sure you've got your coffee. Make sure you've got your brain on. It's going to be a fun session. So pop in the chat. Let us know where you're calling in from. We're seeing people from literally around the world. Serbia, Nashville, Tennessee. That's also on my list. And our friend from Intel, Josh, is also helping out. Josh and I are here in Santa Clara at Intel HQ. It's actually my first time here, so it's fun to be here. San Jose. So Vitu is probably, I can probably see them where they're sitting. So let's let the room fill up for a couple more minutes, and then we'll get started. Make sure to pop in where you're calling from. And then if you've already answered that question, I'm going to ask you another one. So Neil Sampson says, will we have access to this presentation beyond today? We are recording this, and you will be able to rewatch it at your leisure. So the second question I love everybody to answer is, why are you here? Why did you decide to attend this session? You could even tell us a little bit about what you do, whatever you feel comfortable sharing. So we'll let people answer for a couple of minutes, and then we'll get going. While we let those answers flow in, let's actually do some introductions. Like I said, I'm your host today. I'm really glad to be here. My name is Ryan Carson. I've been a founder CEO for the past 20 years, and I just joined Intel 3 months ago, and I'm helping us do all things Intel, AI at Intel. So I'm excited about that. And we've got an amazing speaker today, very experienced, great presenter, deeply knowledgeable. We've got Kevin Petrie here today. Kevin, how you doing?
Great, Ryan. Thank you for having me.
Good to have you here. So Kevin is the VP of Research at Bark US, where he manages the research agenda and writes about topics such as data integration, data observability, machine learning, and cloud data platforms. For 25 years, Kevin has deciphered what technology means to practitioners as industry analyst, instructor, marketer, service leader, and tech journalist. He launched a data analytics services team at EMC Pivotal in the Americas and EMEA, and ran field training at the data integration software provider Attunity, which is now part of Click. So really glad to have you here, Kevin. I'm going to read out a couple more of these answers, and we'll get going. We have people calling in from Bellevue and Finland as well. So everybody make sure to pop in the chat, tell us where you're calling in from, but also why are you here today? What do you want to learn? With that, we are going to get rocking and rolling. So Kevin, over to you.
Ryan, thank you very much. And thank you to the Intel community. Great to be here and have this discussion. I think that it's very germane to Intel's community of AI innovators and developers. There's quite a bit going on with artificial intelligence right now. I think it's fair to say that AI is having a moment, especially driven by generative AI. And so I've been doing a lot of research on the intersection of generative AI and data management. There's a growing realization that Gen AI, especially, and any type of artificial intelligence model or technique, is no better than the data that it consumes. The good news is we're making that realization. The bad news is we're also recognizing that data quality, data governance, preparation, and delivery have been challenges for 3 decades. And a lot of enterprises have some work to do there. But what I want to do is focus on optimizing generative AI with vector databases. Vector databases are an emerging data platform to help govern, organize, deliver data to support generative AI language models. I'll define what those are, why they matter, and how to go about taking advantage of vector databases. I'll also talk about market evolution because this is a point in time, but it's fair to say that good technologies tend to converge and overlap and cross-pollinate. So I think that vector databases, in all likelihood, will morph into something we might call an AI database. I'll talk more about what I mean by that. Okay, so we're going to advance our slide. Good. So let's set the table. The starter gun fired in November 2022 when OpenAI came out with version 3.5 of ChatGPT, which captured the world's imagination. Consumers and employees of all types started realizing the power, the speed, the range, and sophistication of what they could get back by posing all sorts of questions to language models. Google shortly followed with Bard, now Gemini. Hugging Face has had Bloom out there for a while. There's also Llama released, an open source project released by Meta and so forth. So a lot of these Gen AI platforms are being used now, not just by consumers, but also employees as tools to assist productivity. They're using them as standalone platforms or advisors. We're also well into phase 2, which is Gen AI assistance. And now there's this co-pilot phase moving from, Ryan, go ahead.
Hey, everybody. Just a reminder to pop your questions in the questions and answers section. So Kevin is going to be tackling those at the end of the show. We'll curate them. So it's right next to the chat. Please do that. Also, please keep those comments and chats coming in. Love to see them. And we will do our best to react live. So pop your questions in. We'll answer them at the end. Thanks, everybody. Thanks, Kevin. Carry on.
Yes, please. Thank you. I love conversations, dialogue, feedback. Very active on LinkedIn in that regard. So please, as Ryan said, keep it coming. So we're in phase 2, Gen AI assistance, where there's co-pilots that are language model assistants within various productivity tools or other software platforms. Einstein within Salesforce, Copilot within GitHub, Joule within SAP, and so forth are good examples of that. Today's focus is phase 3, and we're well into that, which is that companies, recognizing the incredible opportunity, are starting to build language model functions into multifaceted workflows. So they're starting to take advantage of custom tools, applications, and integrations in order to bake these language model capabilities right into their own applications, and thereby not just improve productivity, but gain competitive advantage. What we're finding is that large language models arguably are becoming small for 2 reasons. One is that parameter counts are coming down, meaning the number of interdependencies and relationships related to a given training corpus of content is going down, so that it becomes easier to fine-tune these things and deploy them. The other is that the dependency on domain-specific data is going up. ChatGPT essentially scraped everything it could find on the internet, got a subset of that, and then went to town in terms of training its model. What companies are doing now is saying, okay, let's start to really apply this to our data, because that's where we have, if we can get the data right, a competitive advantage. And so that is the focus here. So there are 3 different architectural approaches to these domain-specific small language models. I'll use the term language model generically. You could build it from scratch. If you're a pretty sophisticated tech company, you can collect and prepare your own corpus of training content. You can design and train your language model. You'll probably get some good accuracy if you can do it, and you'll sort of understand the domain-specific ways in which your community of people use language. Cons are a lot of money, a lot of sophistication in terms of data science expertise required, and the money is, in particular in compute requirements here. the estimates of what it took OpenAI, I think, are about $100 million in terms of computing requirements for ChatGPT, and I believe that's version 4. So that's a big undertaking. I think most companies, the vast majority of companies, are not going to build their own. They're not going to build from scratch. Rather, they're going to fine-tune or enrich the prompts. And so fine-tuning is where you fine-tune a pre-trained language model, perhaps ChatGPT, perhaps Llama, and so forth, on your own domain-specific data in order to understand the specialized ways in which your community of stakeholders uses language or handles imagery and so forth. You could do this on a lot less data than you'd think, and it can be pretty effective in that regard. It does require data science expertise, and it does require some compute investment. The most common approach to get accurate responses on your own domain-specific data is the third here, enriching LM prompts, which is retrieval-augmented generation. RAG is a term that's getting a lot of attention. Now, RAG is where you can inject your own domain-specific content into the prompt that the user enters into the language model. So essentially, you're giving the language model an open book test. And so Google, in particular with Gemini, has greatly expanded the amount of data it can take in, what they call a context window. So they've greatly expanded the amount of data they can take in to support RAG, and you can improve the accuracy. You picture asking a language model that's focused on how automotive parts work together or how Ford trucks work. You put the entire product manual and engineering manual into the prompt, and then you start asking some specialized questions. You're going to increase the odds, certainly not get to 100%, but you're going to increase the odds that you get the right answer. This does require a lot of reliance on data pipelines, and that's where the vector database comes in. So the vector database can support all three of these approaches. I think that it can support fine-tuning because data science teams can call up and filter and cull the right content to create their training corpus and fine-tune that language model. It also supports, in a big way, RAG, because it's helping you pull up your own domain-specific data. So I'll add one more point about what type of data structures are required here, and then I'll take us into the vector database conversation. Generative AI needs new models and new structures. So if we were to take the example of text, and a common example of text here in the United States, I'm sure others have heard of it, the Declaration of Independence, which is timely. We've got 4th of July, Independence Day, coming up here in the United States next week. It starts when in the course of human events and then goes through a preamble, a body, a lot of bulleted reasons why King George III wasn't a great guy. What you want to do is you want to take all the words, convert them into tokens, which essentially you can picture individual words becoming part of a CSV file separated by commas. So you're starting to create the words into numbers and quantify the meaning of the words and their interrelationships. Then you want to divide the actual training corpus, in this case, different sections of our training document, the preamble, the body, the conclusion, into chunks. So you want to choose the right chunking technique to divide up your source content. Now you're going to use an embedding model to create parameters. They're also just called embeddings, which will start to define the semantic meaning and the interrelationships of different chunks and tokens. So this is where we're taking unstructured data, in our example, text. It can apply to video imagery and so forth too. And we're, in a statistical way, measuring the meaning, assigning words to those numbers, and, assigning numbers to the content, to the words. And we're measuring the interrelationships and the similarity between different words. There's a similarity between when and human in this case. And so we're assigning numbers to that. At that point, you've got essentially vectors that are going to be embedded into a vector database. So you can picture the vector database as a way to take unstructured content and statistically measure the meaning and the interrelationships of all its little bits. Now, the attention network is part of the generative AI model, and it's going to use parameters to weight the influence of tokens, essentially weight the influence of the inputs on the outputs. So in the end, you have a massive calculator, a massive numerical calculator that's going to crunch an incredible amount of data, of numbers, in order to predict the next word in a string of text when prompted, or predict the next image in a string of video imagery and so forth when prompted. So fundamentally, a Gen AI language model doesn't know anything, but it's using statistical probability to predict what it thinks would be similar to the right answer. And the vector database is serving up this data. So the vector database captures all this, what we call high dimension data, meaning that in this case, each chunk has a lot of different features to it because it's related to a lot of different things. And it's going to index all these vectors that measure things, and it's going to index them based on their similarity. How similar is this image to another image? How similar is this word to another word? It's then going to govern access to those vectors, also called embeddings, and it's going to perform DML operations, meaning it's going to accept updates, insertions, deletions from source data that comes into the vector database to make sure that the data in the vector database is current. So now, when a generative AI application that contains the language model comes along and asks for a question, the vector database is going to run a search, find content, vectors that it thinks are pretty darn similar to what the user might want, and serve it up. And that becomes part of the prompt or becomes part of the fine-tuning process. And this is a way in which you can coax that language model to generate a good answer. And it's a primary way companies start applying these powerful language models, let's say Llama 3, to its own data. The opportunity is incredible. The likelihood that you're going to get things a little bit wrong is pretty high right now. And that's why things like vector databases matter, because you're trying to structure and organize all this content in a statistically reliable way. All right, so I want to give a quick example to show what I mean by a search and a similarity search or a semantic search. This example is from Prashant Rao, who's got a great technical blog. I recommend checking it out, I believe on Medium. Vector databases are storing numbers, organizing and retrieving numbers that characterize how similar or dissimilar different objects are. And so if we think of rosé wine, it's not quite white wine, it's not quite red wine. It's in between. So in this case, we can assign numbers, a vector on a graph that's showing how similar it is to white wine, how similar it is to red wine. And we've got two different examples of rosé wine. I'm not very sophisticated when it comes to wine, so I will take Prashant's word for it that Stony Brook Mountain 1997 Estate Reserve Zinfandel from Napa Valley is closer to white than it is to red, and then Colorado Estate is a little closer to red than it is to white. But you can picture a space that is capturing the similarities and the numbers that are associated with these different inputs. Okay, so as companies start to think about a vector database and how they might want to get started using a vector database to organize and search and retrieve all their previously unstructured content to support a Gen AI language model, there are really 5 high-level must-have requirements. These adjectives apply to a lot of categories of technology: ease of use, performance and scalability, ecosystem support, and governance. The details obviously vary in very important ways. If we look at vector databases, the ease of use matters because you've got data engineers, machine learning engineers, data scientists, perhaps developers that are going to be using this system. And you want to make sure that there's an intuitive process for deploying the vector database, for interacting with it, issuing commands, and also configuring the index so that you can organize and retrieve the vectors as you need. Performance and scalability matter quite a bit. Most organizations, according to our survey data, are in the phase of assessing or maybe experimenting with Gen AI, and a number of them have started to experiment with vector databases, but it's early stages. And so a lot of the workloads in the data sets are kind of small right now. But as you start to think about going into limited production or full production across a business unit or across a full enterprise, you want to make sure that you can meet your business requirements over time as you scale. Hi, Ryan.
Howdy. Hey, everybody. First of all, just a quick reminder, pop your questions in the Q&A section or say hello in the chat as well. Kevin, your mic is amazing, but it's picking up when you touch your table a little bit when you move around. So just be aware of that.
So I'm going to try not to pound the table there.
A little bit.
I get
and then
excited.
it's a good reason. So I do have a question about vectors. So could you go back to the wine example?
Yeah.
And I've heard that the smarter that you prompt, the smarter that you get the output. And supposedly when you prompt engineer and say, okay, you are a wine expert, especially on wines from Toscana and the coastal region, that it starts to put the LLM in the vector space of wine tokens. And therefore you tend to get answers that are closer related to the vectors that are expert level. Is there any truth to that?
That's very well described and very true. Very much. And so when I use my version of ChatGPT 4 Plus, I always start with a compliment. You are an expert in X. And then I ask specifically for length and help it categorize the topic as much as possible and the length of the answer. But that's very true. That's very much. So the more you can help it organize and narrow in on the right embeddings and vectors within its index, the better.
Fab. All right. Thank you very much. And engineer, you can turn me off. Everybody have a good time.
Okay, good. All right. So I'm going to watch my hands here. So let's go to the next slide. Performance and scalability. I think we've covered that. As with any system, as with any data platform, we want to make sure that as you scale over time, you can handle those workloads. Most of these vector databases, there are two categories, which I'll talk about. One are the emerging sort of pure plays, Pinecone, Weaviate, Qdrint are three examples. There are others too. Are gonna depend. A lot of those will depend on cloud native storage underneath and cloud computing infrastructure from the big three cloud providers. So scalability can certainly happen, but you want to be able to flexibly handle bursty workloads during certain times. Maybe it's Cyber Monday or Black Friday from a retail perspective. And give visibility into how much it's going to cost to leverage those resources. The range of functionality is actually an important one here. You want to have vector capabilities. It would also be ideal if you could support knowledge graphs that create illustrations and calculations about the relationships between a lot of different entities. It also helps to be able to do keyword search. That works. If you can do keyword matching within documents, you can help triangulate the content you're retrieving beyond the approximation value that you're going to get with the Gen AI language model. Relational capabilities, SQL queries of trusted tables to find facts that are vetted and governed. It's a great way to make sure you got the right facts. And facts matter now more than ever because you really don't want a hallucination where the Gen AI language model is going to make stuff up to impress you. It's kind of like this very smart 18-year-olds, eager to please, but not a lot of business context or inability to know what it doesn't know. So if you can increase the range of functionality, the types of models and the type of content you're serving up to these models, you can really triangulate, enrich, and improve the accuracy of what the system delivers. Ecosystem support matters. You'll want to support the various public language models and have unfettered access to and interoperability with different programming languages, Python. You want to support different predictive ML model libraries and all three of the major cloud infrastructure providers, all of whom should be running Intel chips. I'm kidding in the sense that we don't recommend platforms, but I know that's the there's a subtext here in terms of all this requiring a fair amount of computing power. Now, governance matters too. As with any data platform, you want to govern, oversee, and control access, user activities. You want to be able to selectively mask data in order to remove and avoid sharing or anonymize personally identifiable data in order to comply with, for example, GDPR in Europe or the California Consumer Privacy Act here in the US. Encryption certainly helps in that regard, and you'll want some audit logging to support compliance reports. So these are all things that you want to have within the vector database that you evaluate. So the use cases here are really important. Vector databases are going to support, as I said before, the fine-tuning of the language model and retrieval-augmented generation. And as I alluded on the prior slide, ideally you want to support other types of models, machine learning models, which might be predicting things based on facts from tables, from rows and columns. It's a little more of a mature aspect or angle on machine learning. And so you might, if you're generating text with the language model to interact with customers, you might use a machine learning model to classify or even recommend a product they should buy. Or you might simply use SQL to pull up the exact value that you can hang your hat on of their most recent purchase. Natural language processing can, in a more simple way, but in a complementary way, categorize text. It can help classify user sentiment. So vector databases are going to support one or more of these use cases. They're going to broaden their capabilities to become more of an AI database, as I was saying. So you can picture not just Gen AI as a standalone product or a project, but rather a feature within multifaceted workflows and applications. And the vector database, becoming the AI database, supports all that. All right, so retrieval-augmented generation, I think, as I mentioned before, is really recognized as the primary, most reliable way to, in phase one, or I should say in the early stages of phase three, apply your data, feed your data that you trust into a language model and increase the odds that you'll get a good answer. It's an open book test. And so a common scenario for doing this is to pose a question and then have LangChain orchestrate what happens next, the workflow, where you have an embedding model that's used to pull up the right vectors based on nearest neighbor searches or other types of similarity searches. And that in turn is going to prompt the language model, which will generate an answer that the Gen AI language, that the language model provides, and then the application, probably using a chatbot or something similar, delivers that answer to a human, potentially wrapping text around inputs, numbers, and so forth that it gets from other types of models. Okay, so as I said, this is a point in time and the market is evolving. We've done some survey work. This was somewhat of an informal survey on LinkedIn. And we said, do you believe vector databases are more compelling as pure play offerings or part of database suites? And I think the emerging trend is for suites. So that's where you see that companies such as Vespa, which is a startup and a client of ours as well, is offering vector search capabilities. It's also offering keyword search. It's also delivering tables or entries from tables to support machine learning models. So there are ways in which these platforms are starting to broaden out. And we're seeing broader-based incumbent data platforms, MongoDB, Databricks, Snowflake, and so forth, are adding vector capabilities to what they already do. So over time, it's my belief that vector databases will become part of what we might call an AI database, where you're organizing and searching tables, text, vectors. Those feed AI models that an application uses the AI database to learn, run references, create content, and it will do this with machine learning models, natural language processing models, and of course, Gen AI language models. All that's fed into an application that will evaluate, it'll orchestrate actions, assign actions to different models, evaluate the outputs, and then take action based on that. All right. So if we look at how to get started today with vector databases that are out there, I think there are 4 critical success factors. The first is, of course, training and collaboration. There are a number of different roles. The titles will vary within organizations based on company size, vertical, tradition, heritage, and so forth. There are data engineers who are tasked with preparing data in general. They're very good at tables. They're learning how to handle unstructured data such as text and video and audio that'll go into vector databases. There are also machine learning engineers. There are data scientists. So the data scientists are going to build and train the models. Machine learning engineers are going to put them into production. Natural language processing engineers have the background and the sophisticated understanding of how to handle text. So they're going to be close advisors in a lot of this. And there are other types of ops engineers, cloud ops engineers, and so forth. So you want to make sure that all these different stakeholders are on the same page, getting trained on common best practices and so forth. Data preparation techniques are important. There are different ways to tokenize data. There are different chunking techniques that you could define a fixed chunk size. You could define policies on whether to truncate sentences. You can define policies that are more nuanced and aware of the type of content as they divide it up into chunks. Maybe you want chunks to overlap to retain your semantic meaning in a given case. And then, of course, the choice of embedding model matters quite a bit, because that's figuring out how to create the numbers that represent all the sophisticated meanings and interrelationships of all your chunks and tokens. Data governance is obviously critical. And so most organizations have some semblance, perhaps something very sophisticated when it comes to a data governance program. You need to start to figure out how to adapt that to address the unique and high stakes risks associated with AI, how to handle the unstructured data, how to handle the outputs. And then, so that gets into policies and standards, rules, and so forth to address all types of inputs and all types of outputs. Excuse me. And finally, there's orchestration. It's my belief that these models are pretty darn good from a mathematical perspective. That's not the problem to solve anymore. The problem is twofold. One is the quality of the data. How do you organize it and govern it? Vector databases and AI databases can help there. And then the other problem is how you make all this stuff work together. The old and the new needs to become part of an orchestrated workflow. So you need to test these tasks, schedule handoffs and tasks between all of that, execute, monitor, and optimize your workflows. Hello, Ryan.
Hello. We're almost done. I know we're about to wrap up, so I just want to encourage everybody to pop your questions in the questions and answer section. We'll go through those. You can see the panels jiggling, so make sure to pop them in there, and we'll get started. So why don't you complete that final thought, Kevin, and then I'll start feeding you some questions.
Okay, good. I was about to cut to my thoughtful picture of a dog here. I think the final point would just be keep your eyes on these 4 success factors as you figure out how to amend your data strategy, build unstructured data into it, and start to take advantage of new Gen AI language models. Vector databases have a big role to play, but some of the fundamentals need to be applied to that. Training and collaboration, data prep, orchestration, and data governance. Okay, Ryan, why don't I cut over to you? I've been talking for a while here. Try not to pound the table.
You've done great. Thank you so much, everybody. Appreciate being here. We have 134 people in the audience, so it's fun to see you all here. I have a quick question, then I'm going to go to everyone's question. So say that your information updates and you need to refresh the vector stored. How does that kind of work? Like as you update database, walk everybody through kind of at a high level how that works.
Okay. Great question. So the most common use for that is going to be RAG, because retrieval-augmented generation. You want to pull up the latest, freshest data from within your domain-specific data to make sure that the language model has the latest stuff. Because in all likelihood, you're getting a pre-trained model, let's say ChatGPT-4, that was trained up until a certain point in period of time. So it's not going to know what happened in Ukraine last month. You want to pull up that information and put it in there. So that's the why. But in terms of the how, there's a new class of data pipelines that go through the steps we talked about here: tokenization, vectorization, applying embedding model, chunking, of course, before that. And so you can configure these pipelines that will handle batches of data up front. Then they'll handle incremental batches or updates, let's say on a daily or weekly basis. It could even stream in events using things like Apache Kafka or Apache Pulsar, where you could have real-time events that are sent into vector database form. And so that would support, let's say if you're using Gen AI to, I'm thinking aloud here, generate alerts and sending them to merchants to flag real-time fraud risk. You want to move fast, you want to have the latest information. And so that's where you might want to make sure that you've got the latest refresh through your data pipeline that's handling those incremental batches and even streaming events on a real-time basis.
Yeah, because I'm more traditionally trained on, a SQL type of database where you think, okay, I have a
Yeah.
row of data, and
Yep.
normally you'd update the row and the database would be updated, but we have a vector database which is just tokens, and the vector database doesn't know about rows or columns. So if you want to update a part of the data in your RAG, does it recreate the entire vector database?
It's going to vary by implementation, but you want to perform similar DML operations. But it's on units, so it's on the vectors. So you might insert something, you might update something, or you might remove or replace. So inserts, updates, and deletes, which are common aspects of what companies need to do all the time to tables. It's those similar operations, except you're performing it on vectors, where you might be replacing incremental pieces, you might be updating or revising, or you might be pulling something out entirely.
Awesome. Um,
Yeah.
and and we're not promoting any particular solutions here, but I was playing around with DataStax's vector database tool called
Yeah.
Astra, and
Yeah.
was really impressed with how easy this is. Kind of a pip install, type of thing now. So it's fun to see how easy it is to start using vector data stores. So let's go to some questions. Alexander Sturkin said, "Isn't RAG in fact modifying the prompt to become much bigger and hence slowing down the processing?"
Um, Great question. It does increase the prompt size in almost all cases. So you could have a user that enters a sentence or a paragraph, and then if you picture the customer service application, that's a good primary example, or a developer. Those are two primary use cases. In both cases, you're going to want to pull up a fair amount of content and couple it, inject it into the prompt. So yes, that's going to increase processing, and that's not bad news for Intel. It's got a cost associated with it, but I think that there's a recognition that the processing overhead of RAG is worth it, and I think the latency is not too onerous initially. With that said, so many of the implementations right now are pilots or limited production. So I think going into production, full production scale, is another hurdle where you are going to be slowing things down, creating a lot of processing overhead. Um,
Yep.
so that's another way in which computing can become a bottleneck. I think
Yes.
there are other bigger bottlenecks in terms of cost, which is just fine tuning or training your own from scratch. That's where you need massive
Right.
new electricity farms and so forth.
Yes. And in your excitement, you're beginning to tap your amazing mic again. So
Oh,
just
I
a friendly
apologize
reminder
for
on
that.
that. It's okay. It's a great mic. So we're also seeing the genesis of local, SLMs using RAG, straight on device, right, without even having to go up to the cloud, which would obviously increase privacy and also decrease latency. So I'm excited to see more local RAG solutions. So we've got another question from
Yeah.
Yogesh. They said, "What are the most popular open source vector stores used by language models and enterprises? What are a few that you know of?"
So that's a great question. I know more of the commercial offerings, and some of them might make use of open source. But I think that if you look at the open source movement applies much more to the language models themselves. So Llama 3 is a great example. If you look at the vector databases, the most common ones that we see taking hold are Qdrant, Vespa, Weaviate, and Pinecone. And I think that they might make use of open source technology, but I've seen much less acceptance of open source on the vector side than on the model side.
Yep. Yeah, and some of these solutions now are kind of a pip install. It's really easy to try this. I encourage everybody here to try, a Weaviate or a Pinecone, or just try to set up a small, quick local RAG and get your hands dirty on that. We got a question from Sanjay Kumar. They said, I would like to know what are the open source databases to manage knowledge graphs that are out there? What are you hearing is the most popular?
In terms of knowledge graphs, that's actually an area I've spent less time on. I know that there is a fair amount in terms of evaluating different knowledge graphs. That's something where we're starting some research. But what I have seen is a growing awareness that knowledge graphs can really enrich what you're doing on the prompt side for database for Gen AI language models, because you can give the language model sort of an ontology or a set of relationships that really define how you're organizing content. And there's a fair amount of excitement. I've talked to 3 or 4 different practitioners who are using knowledge graphs and starting to use them to build structures that can help guide what the model is fine-tuned on or how it's prompted. But I haven't looked in detail at what types of knowledge graphs apply, most directly to this.
Fair. Yogesh also asked, does GitHub Copilot use a vector store, or is it based on a different arrangement, such as index search or hybrid approach? And I assume he or she is talking about when you have a local repo that you're working on. How is GitHub Copilot specifically referencing that almost sort of form of RAG?
Yeah, it's a good question. I don't know. I haven't used it myself. I think that GitHub is getting a fair amount of traction. It's probably one of the most popular implementations of these Gen AI copilots. And
I've got a little
I believe it takes advantage of both. Yeah, please. I'd love to hear it.
So the 2 popular tools are obviously VS Code with the GitHub Copilot extension, or I actually use Cursor, which is a VS Code fork that has a large language model built right in, and they do use a vector store. So essentially what you do is you ask it to index the repo that you're working on locally, and it actually embeds it and turns it in a vector store, and then does essentially RAG on it. And it's great because then you're not getting hallucinations about random bits of code. You're actually using your repo to get much better results. Let's keep going. Got a couple more questions. This is great. Everybody keep them coming in. So Anerban said, are there vector databases specifically suited to run on the device, like a laptop or workstation, or are they suited to the cloud, or both? Why don't you walk people through that?
Yeah, I think so it's interesting. I think most implementations so far are cloud-based. There is a growing demand for organizations to take data, to have the data pipeline start with on-premises data, and potentially even maintain the vector database on premises. I have seen far less adoption of folks within devices themselves. Obviously what Apple's doing in terms of locating the Gen AI language model within the device is pretty darn interesting, but I have not seen a lot of adoption yet of vector databases within specific devices. it can start to make sense. There's more and more recognition that these small large language models can have a pretty small footprint. And when I say smaller language model, I mean that you've got its core capabilities, but it's being applied to a smaller set of domain specific data. So it will be on the rise, but because we're in such early days, most of the implementations are taking advantage of cloud platforms right now.
Yep. Just to echo what Kevin's saying, we're seeing a lot of people use an SLM, a small language model like a Phi-3, which is an open source model that came out of Microsoft to run on device. And that allows you to be completely private, right? You don't have to send anything to the cloud, and you can run entire model plus the RAG solution locally. And I'm with you, Kevin. I think it's very interesting, and we'll probably see most mobile devices do this largely on device, private, offline inference on local data, because no one's going to want to send their private, precious data on their phone, for instance, up to a cloud. It just won't feel right to most people. So it'll be interesting to see how that shakes out.
Yeah, and that's one of the reasons that that open source approaches to language models are getting such uptake, because people are not worried about what a commercial vendor might be doing with that data on the back end.
Yep, absolutely. Got some more great questions. This is fabulous. Y'all keep them coming in. All right. What Marashi says, what if teams don't have all of, a team of data engineers? Are there any tools that can do a lot of the sophisticated heavy lifting here? What are your thoughts on that?
Good. I was struck that McKinsey, which I think has done some pretty good research in this area, recommended that, this is a few months ago, for leaders of IT, of data, and even business, don't worry about hiring the data scientists. They're not the bottleneck anymore. Hire data engineers. I did a poll on LinkedIn, and I said, this is January. Do you expect demand for data engineers to go up or down this year? And it was 85% out of 300 respondents said it's going to go up. And so the implication was that even though Gen AI automates what some data engineers do, the net consumption of what they do is going up hugely. The demand for their services is going up hugely. So we need more of them. So data engineers are a bottleneck, no question. There are definitely some tools that can help you take unstructured text or other types of unstructured data and start to organize it and perform those transformation steps I described to put it into a vector database. So some of the ones that come to mind are Datavolo. They're also a client of ours. There's unstructured.io. Flexor is another one. And there are others as well. I think Unstract is involved in handling some of this. And then you've also got some of the existing players that are starting to get involved here. And Airbyte is one, and there are some others too. I think that Prophecy, also a former client of mine, is starting to help convert the unstructured data and feed it into vector databases. And they're doing it in ways that automate the process and make it easier and provide some guidance about chunking techniques and so forth. With that said, you do want data engineers who are smart and can help figure this out.
Right. Absolutely. And the great thing is now we have large language models that can teach you a lot of the basics of data engineering. So you can start to actually do some of this yourself. And I encourage everybody to try and see how far you can get. We've never had access to always on, always helpful, always encouraging, almost all knowing tutors before. And now we do.
Yes.
It's either free if you
they never get tired.
Yeah. Never get tired. They're always helpful. They always want you to win. And they're never judgmental. So that's how I learn everything now. So on that note of running models locally, this is why at Intel we're so excited about AI PCs and this reality of having neural processing units on device where we can start to offload some of these AI workloads and run things locally. And our strong opinion is this is where all local compute is going, where you're running a lot of the AI workloads on device. So we've got Core Ultra and coming up Lunar Lake, and we're really excited about people running AI on device. So got a couple more questions and then we're going to be out of time. This is great to see you all popping these questions in. Let's see. We've got a question from Anerban. This is a good one. Can fine-tuning LLMs provide more accurate results than RAG?
It can. Yeah, it's going to depend. So I think a common pattern for a lot of companies is to start with RAG and then mature and go to fine-tuning. But with that said, for now, I think, and I put out a LinkedIn post on this that got spirited discussion on both sides of the debate. I think most companies for now don't need to fine-tune. And so the reason is that fine-tuning is going to help when you have domain-specific ways in which certain communities of users use words or imagery or things like that. So picture doctors, lawyers, bankers, those types of people are going to use language, if we're using the example of text, in specialized ways, their own vocabulary, their own way of looking at things. And that's where it really makes sense to have a fine-tuned language model that understands those nuances rather than a ChatGPT that's trained on the web. So that's an early use case for fine-tuning where it will help and, in fact, almost be necessary, in my view, to help lawyers do things that are trustworthy and so forth, in addition to RAG. But if you're looking to get facts right, then RAG is kind of the best way to go. You pull up something with a SQL query from your SAP database, and it's vetted, governed financial records. You can hang your hat on those numbers, and you can put it into the prompt and have some confidence that it's going to get the answer right.
Got it. I feel like there's another hot debate that's beginning to happen as we see the context window for Gemini increase to 2 million tokens. You can load a lot of what you used to load into a RAG into the context, and now you have context caching on top of that. And so you really don't have to build a RAG, some people say now, if you have these large context windows. And I assume we'll see large context windows and caching, with state-of-the-art open models too soon. So how should people think about that?
It's a good question. And so I think it's going to vary by use case. But you're right. If you have this huge context window, the onus is then on the user, the person entering the prompt, to give very specific instructions about what to do with all the information they're throwing at them. So if I'm going to throw the Encyclopedia Britannica at this thing, I really want to be clear about what the heck I want it to pull out. And so that's where prompt engineering best practices become important. Assigning a role to the user, the example you used earlier, Ryan, which I liked a lot. Being precise about how to categorize the topic, and then being precise about the length and structure of the response to come back. And then asking for it to cite and highlight the passages that it got that information from. And if you do those things, then yeah, it's gonna be pretty cool. And you could have a user do it, or you could have applications start to generate this stuff.
Yep.
Yeah. Interesting
that
possibilities.
Makes sense. Yeah, I think, and it will constantly evolve and quickly change, I'm sure, but it does feel like we're moving into a world where, the huge amounts of data that we have behind our firewalls, that is, not on public clouds, that feels like it's going to be RAG. And then we will probably load smaller, data sets that we need quicker access to easier into the context window. And we'll probably have some sort of amalgamation of both of these solutions. So stay tuned, everybody. We'll see how it finishes up. Let's finish with one final question from June. They said, is there a potential loss of information when retrieving data from a vector database compared to retrieving the original data directly?
There is very much. And so that's where things get tricky. You can only do so much in terms of the precision with which you calculate similarity to pull up the right vectors and the right chunks associated with that. And that's where coupling vector search with keyword matching becomes pretty powerful, because then if you put in a finite set of documents and just say find this exact phrase, and you pull up that document, and that's a document you have confidence in, that's pretty good. And then you couple that with the summarization of that document by the Gen AI language model. That gives you higher confidence level that you're not missing important factors than simply having the Gen AI language model go fishing and see what it finds.
Got it. I actually want to squeeze one more question in from
Yeah.
Peter. They said, what kind of tools are being used to prepare, blend, transform, for example, data pipelining, and clean corpus source data before it's loaded into the vector DB? Is that functionality included in the vector DB, or are those separate tool sets?
Yeah, great question. I think the vendors that I mentioned earlier are going to be helping with a lot of that. And so that's where you've got Datavolo, Flexor, Unstructured.io, Unstract that are going to help with that process. And then companies like Airbyte and Prophecy that are getting into it as well.
Got it.
I think as with all these technologies, you'll see platform companies start to help with that, whether it's OpenAI or database companies, but you still need the independent platform providers that can work across infrastructure domains and across resources, whether it's on-prem or multiple clouds. So that independent class of data pipeline companies will remain important.
Perfect. Well, we're going to wind it up there, folks. Kevin, thank you so much for spending your valuable time with us, for sharing your even more valuable knowledge and experience. We really appreciate you being here. I know you're active on LinkedIn. Where can people find you on LinkedIn?
Yeah, I think it's LinkedIn, Kevin Petrie Tech, and I post on a daily basis, get some good discussion from early adopters, folks wanting to get smarter, and all of the above. So find me there. I would love to connect. Would love to hear thoughts on this discussion.
Perfect. Thank you so much. Everybody, thanks for joining you. We at Intel are really excited about empowering you as AI developers and as AI solution architects. We want to give you the compute you need and the solutions you need to make it all happen. We're particularly excited about all of the power that we're bringing down onto the device with AI PCs, and look forward to you running these AI workloads on your device with privacy, speed, and security. So everybody, thanks for joining us, and make sure to follow us at x.com/Intel and /Intel AI. And also you can find us on LinkedIn and of course, intel.com. So thanks everybody for joining, and we will see you next time. Take care, everybody.
Fantastic. Thank you very much.